Right, so let's get started. We are on page number 58 of our notes. So I'm going to pull up the PowerPoint and I'm going to have to share my screen first. So let me share the screen and I'm going to bring up this PowerPoint. Okay, so let me go into present mode here. Nope, I don't want to present online. I want to present it from my current slide. Here we go. All right, let me change that to the duplicate. All right, I need to go back. And here we go. Okay. Nope, we're one more ahead here. Sorry, guys. You know, technology. All right, so let me make sure I've got my pen handy. Okay. So matter classified as an atom means atoms are neutral. All right, so neutral. So it means anytime you see the word atom, I want you to write protons equal electrons. That positive protons equal the negative electrons. Electrically neutral. No charge. Net charge equals 0. Net charge, right? That means the overall charge. All the positives and all the negatives added up together is neutral. The number of protons that are positive are equal to the number of electrons that are negative. For example, the element fluorine has the 9 positive protons. And again, just a little bit review. The nuclear charge, right? The charge of the nucleus is positive 9 because there's 9 protons. The neutrons have no charge in the nucleus. And outside the nucleus, we have -9. We have 9 negative electrons. So the overall charge of +9 plus a -9 is equal to 0. So now what is an ion, right? An ion is not an atom. This tiny little word you want to make sure you pay attention to. When you see ion, you write down protons do not equal electrons. The positive does not equal the negative. So an ion is considered a charged particle that has either gained or lost electrons, which leads us to an overall charge of either positive or negative, right? So the protons do not equal the electrons. So we have a cation, and I like to say cations are positive, right? Cat, positive, right? This is why I have all this, that nice smelling soap with the cats on it, because cations are positive charge. So it means they lost electrons, right? So if you have a positive charge, it's a loss of electrons. If you have an anion, right? So I like to think of this as a negative ion. It's a negative charge because it has gained electrons. So we have positive and negative. Let me just, I want to go back really quickly. So then I have, with a cation, I have more positive protons than negative electrons, right? So that gives it a positive charge. If I have an equal charge and I take 1 electron away, I don't have an equal charge anymore. I have more positive charges. So now an anion, I'm going to have more electrons, right? Because you gained an electron. So more negative charge than protons, which are the positive charge. So if you see a positive, that means you take away electrons. If you see the negative, that means you add electrons, because electrons are negative and protons are positive. So let's take a look at, so here are a couple of substances. So we have either atom or ion. So anytime you see the word atom, protons equal electrons. Ion, proton does not equal electrons. So if I have this sodium with this little 0, that means it's an atom. If I see this little +1, that's an ion. This little 0 over here, that is a atom. And this little -1 makes that an ion. So here we have an atom, an ion, an atom, and an ion. Now let's go with our atomic number, right? The atomic number is the identity or the number of protons in the nucleus. So I go to the periodic table, I find the symbol for Na, and the atomic number is 11. Well, that's also sodium. The atomic number is 11, right? Still sodium. Fluorine's atomic number is 9, and that fluorine ion is also atomic number 9, because the identity doesn't change. So now if we go to the mass, right, we're going to use the rounded mass on the periodic table. These two sodiums have the same mass, even though we have a particle loss. Why does the mass stay the same? Because remember, the mass of the electron is equal to 0. So then there's no change in mass when an electron is lost or gained. So then the mass of fluorine is still 19, and the mass of that fluorine ion is still 19. So now let's look at the number of protons. The number of protons is equal to the atomic number. Right, that's the identity of an element. 11. Well, that's still sodium. It's still atomic number 11. It's still protons are equal to 11. Fluorine's, the atom is atomic number 9, and its ion is also atomic number 9, because that's the identity, and protons don't change. So our neutrons, remember we take our mass minus the atomic number, or the number of protons, right? Because the protons plus the neutrons add up to the mass. So 23 minus 11, 12. 23 minus 11, 12. Again, the neutrons don't change, right? Neutrons are changed when we're talking about isotopes. But when we're talking about ions, there's no change. So we have a 10, because that's 19 minus 9, still 10. Now let's talk about those electrons, right? If I have a neutral atom, that means that the protons that are positive have to equal the negative electrons. So then I have 11 positive protons and 11 negative electrons. Positive 11, negative 11, net charge of 0. Now if I have a positive 1, that means I have to have one more positive charge. It means I have one more proton than electron. So if the protons are 11, that means I have 10 electrons. Or I see a positive 1, that means I take one electron away, because I need to have one more positive charge, 11, than negative charge, 10. So now I have a neutral atom, right? And so that means that my protons and my electrons are going to be equal. Protons equal electrons. So now if I have a negative 1, that means I have more electrons than protons, because I have more negative charge than positive charge. How much more? Minus 1, one more. So that means I see the minus, that means I'm going to add one electron. So that means I'm going to add one electron. And atoms lose or gain electrons to achieve what we call a stable electron configuration. So I like to do stable electron configuration. Like a noble gas. And we'll talk about those noble gases in a bit. So let's go on to our next slide. And what is the periodic table? Well, the periodic table is a chart used to organize the elements based upon the atomic number, or the number of protons. And so the periods are the rows, right? So then that goes, right? That's what the row. And there's 7 horizontal lines. So there's 7 rows, 7 periods. And then groups or families are the vertical columns, right? Groups or families are the vertical columns, right? Those go up and down. So I'm going to just go to the, hold on, I want to not, I'm going to discard my annotations. And I want to go and I want to show you the periodic table, the elements here. So let's just make this a little bit bigger. And so here we have, I want to just show you the charges, right? So then here we have, I'm just going to use this bigger. So this -4 means that this is an ion. So one of the possible ions of carbon is a -4. And if you have a -4, that means it gains 4 extra electrons. So it has 4 more negative charges than positive charges. So if I have a neutral carbon, I would have 6 electrons. So now I want to have 10 total electrons because it gained 10 total electrons. That's what we call achieving a noble gas configuration, which is over here. These are our noble gases. That's our noble gas group or our noble gas family. So when carbon gains those 4 electrons, it achieves a stable configuration like neon over here with 10 electrons. Now if I look at this +2, right, that means this is a cation because it's positive, right? It's a cation. And that means it loses 2 electrons. So instead of having 6 and 6, it only now has how many, right? So if I lose 2 electrons, that means it's going to be a 4 electrons, right? So it's going to be 4 electrons. And if I have a +4, that means it's going to have only 2 electrons, right, for +4. So if I go over here, so here I have this fluorine that was in our notes. So here if I have this -2 charge, that means that this is an ion. And then this means that it gained 2 electrons. So now let's go over and let's find one that's a positive. So here's this beryllium that's a positive. So this means it lost 2 electrons, and this would be a cation. And then over here, let's go back to that oxygen. And then oxygen would be an anion. All right, so that's ions. So then at the top of my periodic table, I might write the word atom. That means that the positive protons equal the negative electrons. And if I have an ion, make that a better I, that means that the positive protons do not equal the negative electrons. That means that there has to be a change in the number of electrons. All right, so hopefully that helps you learn and understand the concept of the ion, which is very important in chemistry. Until our next set of notes, thank you for joining.